Hello everyone, in this session I will continue share with you another example on non-homogeneous system of first order LDE. In this example, the question requires you to find the particular solution for the following non-homogeneous system of first order LDE as below. So this is the metric, the first order linear differential equation with the metric is -3, 1, 2, and -4. Okay, so how are we going to find the particular solution for this? In this question, we know that it is a non-homogeneous first order, the LDE, because of this part. In order to solve this, we divided into few parts. Part 1 is to find the general solution YC for the homogeneous system. Okay, the first step, we know that the y prime equal to ay plus g. So that is from the formula, you know that the y prime is equal to ay plus g. So a from the question is -3, 1, 2, and -4. Y is y plus g. G is referred to this x and exponent. So x and exponent -x. And then the second step is to find the eigenvalue and the eigenvector. Okay, so from the metric, you have the -3, 1, 2, and -4. Again, only this value, these two values, will have to minus with lambda. Okay, and then -3 minus lambda multiply with -4 minus lambda. Okay, minus with 2 times 1 equal to 0. So -3 times with -4 and then times with negative lambda. So you get 12 plus 3 lambda. And then this one multiply with this one again. Plus with 4 lambda plus lambda square minus with 2 equal to 0. When you simplify, you get lambda square plus 7 lambda plus 10 equal to 0. Then you can factorize it. When you factorize, you can get 2 and 5, so plus and plus. So lambda equal to -2 and lambda equal to -5. Okay, so you have two values of lambda. Okay, that is we call an eigenvalue. Now we go to find the eigenvector for the lambda equal to -2. Okay, so you substitute the -2 in the matrix. So -3 plus 2. Okay, you substitute in this lambda with the value of -2. -3 plus 2, 1. 2 and -4 plus 2. Then x and y equal to 0 and 0. So -x plus y equal to 0 because -3 plus 2 you get -1. Multiply with x is a -x. Plus with y times with 1 so you get y, positive y. And then similar to the second row, 2x plus 2x minus with 2y, negative, okay, this one, -2 times with y. So you assume that the x is equal to s, so from here, you get y equal to s. Okay, this one is from here. So your eigenvector is x and y, so you get 1 and 1 s. Then next one is for the lambda equal to -5. So you substitute the -5 into the lambda. Okay, negative 3 plus 5, you get positive 2. So 2 times x, you get 2x plus y equal to 0. Similarly to the second row, 2x plus y equal to 0. So then you assume that the x is equal to s, so you can substitute in either one of the equation, you will get the same value. So y is equal to negative 2s. So the eigenvector is equal to 1 and negative 2s. And the step 3 is to check whether it's linearly independent or not. So you get the eigenvector from the first lambda, that is 1, 1. Okay, 1, 1. And the second eigenvector is 1, negative 2. So 1, 1 and 1, negative 2. So you get multiply with this one and minus with this one. So you have negative 2 minus with 1, which is equivalent to negative 3. And this is not equal to 0. Therefore, I said that this is linearly independent. If not equal to 0, that is linearly independent. If equal to 0, that is not linearly independent. And then step number 4 is the general solution. Okay, general solution for the homogeneous part, that one we call it ycx is equal to c1. And then for the eigenvector, first one is a 1, 1. For the lambda equal to negative 2. And then c2, eigenvector is 1, negative 2. For the eigenvector, for the eigenvalue is negative 5. Means that the eigenvalue same as equal to eigenvalue means that it's a lambda. Okay, so this is the part 1 for the homogeneous part. Then part 2. Okay, part 2 we want to find the yp, because we want to find the yp because it is not homogeneous, it's non-homogeneous, so we need to find the yp. So the first step is we need to assume the yp from the table. So do you still remember what is the g value? G component. So from the equation, the g component is x and exponent negative x. Okay, and therefore we can rewrite the g component. Okay, so this one is equivalent to, if you look at the table, is exponent is different and polynomial is different. Okay, so we can write as, okay, we separate it. If we want to take out the exponent negative x, okay, from this g component, only the second row has the exponent negative x, so this is 1. And as for this polynomial x, okay, so plus with 1, 0 for the x. Okay, do you understand? Okay, in the table, to assume the yp, we only have the case of polynomial, exponent, or trigonometry. So just now, it's a combination of the exponent and the polynomial. So therefore, we need to separate it. Polynomial is polynomial, exponent is exponent. Therefore, we separate it, the polynomial and the exponent. So if we separate the exponent, so this one, when you multiply in, you still get the exponent negative x, right? And then plus with the polynomial. So this one, x times 1, you get x. X times 0, you still get 0. So when you add up, you sum up, you will get the same answer like this. Why I need to do like this? Because we need to fulfill, if you look at the table, we need to fulfill the format. We don't have the mixed one, so we need to separate it. So in this case, we can have the two cases. First one is the exponent, then plus with the polynomial. So for the exponent, you have the u1, u2 exponent lambda x. And for the polynomial, you have the x. So x is this one. So you can have the u1x plus b1 and u2x plus b2. So we can assume our yp. For the exponent, so you have u1, u2 as I told you just now. And for the polynomial, you have v1x plus w1 and v2x plus w2. And then we check. Okay, we use the variable of u, v, and w. So we check whether the yp same as the yc or not. Yc is just now we find it ycx. So we check this yp same as yc or not. Okay, we have the exponent x, this one, negative 5x, negative 2x. So it's not the same. So I can say that yp is not the same with the yc. So we can remain use this yp. And then step 2 is we want to find the we differentiate the yp. So we find the yp prime. So yp prime equal to, you differentiate this one, you get, oh okay, I think this one is a negative mistake here. Okay, so you differentiate, you get negative u1, negative u2, exponent negative x. Okay, negative exponent negative x is follow the question. Okay, and then plus with you differentiate this one, you get v1 and v2. Okay, and then step number 3 is yp prime equal to ay plus g. So yp prime, okay, you write down the yp prime is negative u1, negative u2, exponent negative x plus v1, v2 equal to a. Okay, a is the matrix, so negative 3, 1, 2, negative 4. Y is, okay, y is the yp. Okay, is the latest yp. So you have u1, u2, exponent negative x plus v1, v2, x plus w1, w2. Okay, so this part we call it as a yp. This is this one. Okay, so this part is the a. So ay plus g. Okay, g is 0, 1, exponent negative x plus 1, 0, x. Okay, so this part is g. Now, you can multiply in. This means that the a multiply with u1, u2 exponent negative x, and then a also multiply with this one and multiply with this one as well. Okay? So here you have negative 3 u1 plus u2. And then the second row is 2 u1 minus with 4 u2. Okay? Okay, so this one is exponent negative x. And then second one is negative 3 v1 plus v2. And then second row is 2 v1 minus 4 v2. This is for the x. And then the third one is negative 3 w1 plus w2, and second row is 2 w1 minus 4 w2, then plus with 0, 1 exponent negative x plus 1, 0, x. So if you look at this, actually this one we still can combine. This one can combine, and then this one can combine this one. You can sum up. So end up we have negative 3u1 plus u2, 2u1 minus 4u2. This is remain for the exponent negative x, plus negative 3v1 plus v2 plus 1. Plus 1 is the value of this one. And then 2v1 minus 4v2. This is for the x. And then the third one is negative 3w1 plus w2. Second row is 2w1 minus 4w2. Okay. So the left hand side, we still have negative u1, negative u2 for the exponent negative x, and then plus v1 and v2. And the next step, we want to equating the coefficient. Okay, by comparing the exponent negative x. Okay, compare the exponent negative x. If you look at here, this is exponent negative x, so we want to compare this one. So we take the value of this one. And for the right hand side, this is the exponent negative x, so we will take the value of this one. So negative u1, negative u2 equal to negative 3u1 plus u2, 2u1 minus 4u2. I think I missed out the one here. So this one I should have plus 1. Okay, so I have the plus 1 here, sorry. The plus 1 here. So this one also have plus 1. Okay. So now we have negative 3u1 plus. Okay, we shift the negative u1 to the right hand side, so we have a positive u1. So negative 3u1 plus u1 plus u2 equal to 0. So this one is equivalent to negative 2u1 plus u2 equal to 0. And then we can assume that u2 is equal to 2u1. And this is we assign as equation 1. And then for the second row, we have 2u1 minus 4u2 and then plus u2. Okay, we take it from the left hand side. And then plus with 1 equal to 0. So when you simplify, you get 2u1 minus 3u2 equal to negative 1. So I assume this is equation number 2. So I insert the equation number 1 into equation number 2. So I get 2u1 minus 3u2. So u2 is 2u1 equal to negative 1. So I have negative 2 minus 6. 2 minus 6, you get negative 4. u1 equal to negative 1. So u1 equal to 1 over 4. This is equation number 3. And then I insert the answer for the u1 into equation number 1. Equation number 1 is u2 equal to 2u1. Okay. So u2 equal to 2u1 and u1 is 1 over 4. You get 1 over 2. Okay. Next, I want to compare for the x. Okay, compare for the x. Okay, if you refer back to the question, okay, the last answer I obtained for the x. For the left hand side, I don't have any x, so I obtain 0 and 0. For the right hand side, I have this value. Okay. So 0 and 0. For the right hand side, I have negative 3v1 plus v2 plus 1 and 2v1 minus 4v2. So I write the equation down. Minus 3v1 plus v2 equal to negative 1. 2v1 minus 4v2 equal to 2. So this one is 3v1 minus 1. So I assume this is 1 and this is 2. So equation 1, write down into 2. So I get 2v1 minus 4v2, right, equal to 0. And I substitute the value of v2. Oh, sorry, this is v2 equal to 3v1 minus 1. Okay, 2v1 minus 4, 3v1 minus 1 equal to 0. And then 2v1 minus 12v1 plus 4 equal to 0. So I solve this one, I get negative 10 v1 plus 4 equal to 0. So v1 equal to 4 over 10 equal to 2 over 5. Whereas v2 equal to 3v1 minus 1. And I substitute the value of v1. Then I get the value of 1 over 5. Okay, do you understand? So I write down v1 and v2 equal to negative 3w1 plus w2, 2w1 minus 4w2. Okay. So v1 and v2 that you obtain from the previous is 2 over 5 and 1 over 5. Okay. 2 over 5 equal to negative 3w1 plus w2. So w2 equal to 3w1 plus 2 over 5. So this is name it as equation 3. And v2, okay, v2 is you obtain is 1 over 5 from the previous answer. You get 2w1 minus 4w2. This is name it as equation 4. So I insert the equation 3 into equation 4. I get 1 over 5 equal to 2w1 minus 4w2. w2 is 3w1 plus 2 over 5. So I get 2w1 minus 12w1 minus 8 over 5. So I move the 8 over 5 to the left hand side. So I add up with 1 over 5, I get 9 over 5 equal to negative 10 w1. So w1 equal to 9 over 5 times with 1 over 10 negative. So I get negative 9 over 50. So this is equation number 5. Then I insert equation number 5 into equation number 3. I get w2 equal to 3, negative 9 over 50 plus 2 over 5 equal to negative 7 over 50. So now my yp equal to u1, u2, exponent negative x plus v1x plus w1, v2x plus w2. So we can insert in all the answer. So this is about the part 2 to find the yp. Okay, then next we go to part 3, which is the general solution. It's almost towards the end. General solution is y equal to yc plus yp. Yc just now from the first part, we get C1 equal C1 1 as power negative 2x plus C2 1 negative 2 as power negative 5x plus, okay, the YP, so you copy down the whole thing here. So you get 1 over 4, 1 over 2 as power negative x plus 2 over 5 x minus 9 over 50, 1 over x minus 7 over 50. Okay, so this is part number 3, and part 4 is the initial condition y0 and 0. Okay, 0 0 equal to C1 1 as power 0, because this means that when x equal to 0, y also equal to 0. So we get 0 0, and then this all the x will substitute with the 0. So you get exponent 0. Also same as this one. Then plus with negative 9 over 50, negative 7 over 50. So from here, we can get an equation C1 plus C2 equal to, and we solve this part and this part, we get negative 0.07. So C1 equal to negative 0.07 minus C2. This is equation number 6. And C1 minus 2 C2, so second row, this is we solve this one and this one, we get negative 0.36. This is equation number 7. Okay, so we insert the equation number 6 to equation number 7. We have C1 minus 2C2 equal to negative 0.36. So we substitute the value of C1. So C1 we get negative 0.07 minus C2. Okay, again minus with negative 2C2 equal to negative 0.36. So we solve this one, we get 3C2 equal to 0.29. So C2 equal to 29 over 300. This is equation number 8. And then we have the C2 value, so we insert into the equation number 6. Equation number 6 is C1. Okay, C1 equal to negative 0.07 minus C2. C2 is 29 over 300. So we get negative 1 over 6. So finally, we can write down our answer. Y equal to negative 1 over 6. 1 as power negative 2x. We can write down the answer for the C1 and C2. We substitute the value. Okay, for the C2 is 29 over 300. 1 negative 2 as power negative 5x plus 1 over 4, 1 over 2 as power negative x plus 2 over 5x minus 9 over 50. 1 over 5x minus 7 over 50. Okay, that's all for the solution for the particular for the non-homogeneous system of the first order LDE. It's quite lengthy, but the procedure is quite simple if you follow all the procedure. Okay, hope you can understand and enjoy watching. Thank you very much.